Hello guys, welcome back. So here we have another question on network theory from GATE EC 2015. In the network shown in the figure, all resistors are identical with R equal to 300 ohm. The resistance RAB in ohm of the network is dash. So this is the network and we need to solve this. So this is node B. So if we take this and try to observe, this is going to be simple only, easy to solve. So if you observe these three resistors, you observe these nodes, if you look top or bottom, it's going to be symmetric, right? So all these three nodes, the resistors whatever are here, they are lying between node A and B, right? And they are having equal proportional value. Here it is equal. Even if it is R1, R1 here, R2, R2 here, R3, R3 here, it is going to be symmetric, right? Which means that, so if you have to write it separately, I have one node here, I have R1, R1 here, R2, R2 here. So this is A and let me call this as ground for now, or B, whatever it is. So if you observe, these two voltages are going to be equal. V1, V2 are going to be equal, right? Because it is a symmetric circuit. So now if I connect anything between them, any resistor, anything, there is going to be no current flow through it, right? On the other hand, if this was the original circuit to start with, now I can see that the symmetry still holds and there is no current flowing to R. So I can as well remove this R. So I can remove this R, put some other R, R3, or replace it with a short circuit or replace it with the open circuit. Nothing is going to affect the current flowing in these arms and the voltage values at these nodes. Okay. And also the equivalent impedance looking in it, nothing is going to change irrespective of whatever I do in between these two nodes. So we are going to use the same technique here. What we are going to do, we can either remove these, replace it with a short circuit or open circuit. If you look at here, if we replace it with a short circuit, then all these R's comes in parallel. Down also all R's comes in parallel, and these both together they come in series. So it will be easier for us to solve. So let us proceed with that method. Okay, so we are going to remove this and replace with a short. Okay, so now how many R's are there? 1, 2, 3, 4, 5, 6. 6 R's are in parallel. So what is its effective circuit? This is going to be R by 6, and bottom side also 1, 2, 3, 4, 5, 6. So this is also R by 6. So you have A and B. So what is your effective impedance? It is going to be R by 3. So RAB is equal to R by 3, which is equal to, R is given as 300 ohms. So this is equal to 300 by 3, which is equal to 100 ohms. Okay. So let me also demonstrate for you. If I replace it with the open circuit, what happens? So now let's say it is open. So now shall we try to simplify this? So we have A, R becomes 2R, B, and here these R's are in parallel. So it is R by 2 and it is in series with these R's. So again R by 2. And what about these two? These two also similar, R by 2, R by 2. And then here again 2R. So now if I have to write, so this 2R in parallel with this 2R becomes R, right? So this one and this one becomes this thing. And this becomes R and this becomes R. So it is 3 R's in parallel. So what is the equivalent impedance? It is again R by 3. So irrespective of you either do it the open circuit method or short circuit method, you are going to get the same answer. Okay. So in this way, in this thing, the short circuit was easier. So the answer to this question is 100 ohms.